Welcome to another session with my student Akshit, who is way ahead of competition, scoring almost 100% marks in all his math tests. We'll discuss derivative of trigonometric functions with examination style questions in this particular video. You can also enjoy learning from me by sending an email on the address given. Let us now discuss some real problems with brilliant student Akshit. Hi Akshit, how are you doing?
Hi sir, I'm doing well. How are you?
Very good, very good. So today, what do you want to do?
So today I was hoping we can continue with trigonometric functions and review a few more questions.
Sure. Do you have some questions to share?
Yes, sir. I have a few questions.
Okay, so let's begin from there and then we'll see. You can share.
Okay. Yeah. Number 6, sir.
Okay, can you please read the question?
Yeah. Determine the absolute extreme values of each function on the given interval.
Correct.
And then you can verify results.
Okay, so let's say y equals to cos x plus sin x, where x is between 0 to 2 pi. So let me do it on whiteboard and then,
Okay.
a bit more space to explain it.
Yeah.
So can you please tell me what is the equation given to you?
Yes, sir. Y equals cos x plus sin x on 0 to 2 pi.
You want extreme value. So remember one thing, that whenever you're looking for extreme value, that means what?
So that means you would have to look at the derivative too, right?
Yes, and the value of the function at the two endpoints, which is in this case 0 and 2 pi, right?
Right.
And also at a critical number, right?
Right.
There could be more than one critical numbers, right?
Correct.
So that is what it really means. So let's find the derivative of the function. So what is the derivative of the function? Can you please tell me?
Yes, sir. It would be minus sin x plus cos x.
And to find the critical number, we'll equate it to 0, correct?
Yeah.
That means we get sin x equals to cos x, right?
Right.
You can divide one by the other. So we can write in two steps. Sin x over cos x equals to 1, which is tan x.
Right.
Equals to 1, correct? 0 to 2 pi means that tan will be positive 1 in quadrant 1. You know the cast rule, right?
Yes, sir.
And therefore, we have the solution that is going to be 1 for pi by 4. And so 1 pi by 4, 2, 3, 4, and 1 pi. 5 pi by 4, correct?
Oh, okay. So I think
X is equals to pi by 4.
Yeah.
And also 5 pi by 4, correct?
Correct.
So there are two critical numbers. Therefore, you should also find the value of the function at pi by 4 and at 5 pi by 4. Is it okay?
Yes, sir.
So calculate all these values, right? So those are the critical numbers. We have got two of them. So plug in 0. When you plug in 0, you get 1, right?
Yeah.
When you plug in 2 pi, so again, you'll get 1.
Yeah.
When you plug in pi by 4, what do you get?
Yes, sir.
Both are positive, correct? 1 over square root 2. You can write square root 2 over 2, right?
Yeah.
Which is 2 square root 2.
Oh,
Over 2. So which is square root 2, right?
yeah.
And if it is 5 pi by 4, both are negative, right?
Yeah.
Minus square root 2. So we have absolute maximum at pi by 4 from here when you compare them.
Right.
And we have absolute minimum at 5 pi by 4. You get the idea?
Yes, sir.
So that is how you have to do these questions, right?
Right. So just one clarification.
Yeah.
So I think where I was tripping up was where we equated sin x to cos x, right?
Yeah.
So then I think I did sin x over cos x equals 0 instead of 1, sir.
Oh, I see.
Yeah, so that's why I wasn't getting the right value.
Correct. Now it is clear, right?
Yes, sir. Now it's clear.
Do you want to ask any other question?
Yes, sir. One more question.
Tell me the question, I'll write down, then work on. Tell me.
Yes, sir. So it's a particle moving along a line, and its function at time t for its position is 8 sine of 2t.
Wait. Ft is?
8 sine 2t.
Yeah.
And it says for what values of t does the particle change direction? Okay. So you equate first derivative to 0, right?
Yeah, change direction. Yeah. So only when the derivative becomes from positive to negative or negative to positive, it changes direction.
Right.
Of course, it does that. Do they give you any domain interval?
No, sir. No domain.
Okay. So let's forget about this. So the question is change direction, right? That is the question.
Right.
So find the derivative of the function.
Right. 16 cos 2t.
16 cos 2t. So derivative of sine t is cos 2t, internal 2t is 2 cos 2t.
Yeah.
Equate this to 0. So when you equate this to 0, then when is this function 0? Cos function 0 at odd multiples of pi by 2, right?
Right.
So it is 0 at 2t equals to odd multiples of pi by 2 means 2n plus 1 times pi by 2. Is that okay?
Pi by 2. Yeah.
So where n belongs to integers.
Yeah.
So that is where it is going to be turning. And so t could be equals to pi by 4.
Right.
Un plus 1. Is that clear to you?
Yes, sir.
So those are the multiples, the odd multiples. And since, it changes sign, because you at this point changes sign. So therefore, we know that the change of direction is at these points.
Right.
Is that concept clear?
Yes, sir. It's clear.
So that is a general expression.
Yeah.
Where n belongs to integers.
Sir, so if they said what is the particle's maximum velocity now, then we would just plug in whatever point we got, right?
Yeah. So maximum velocity, these are turning points, right? So as you can see, the function's derivative is, let's just sketch one. Correct. So because the field is pi now, right?
Right.
You can see pi, right?
Yeah.
You see at pi by 4, it is 0, right?
Yes, sir.
Or multiples pi by 4, it is 0. And changes sign because it is the positive and then negative. You see that?
And then negative, yeah.
So it changes sign. So it converts. Now,
right.
You can find where it is maximum minimum by plugging the value.
Right. Yeah.
Right. Is that clear?
Yes, sir. Yes, sir. That's clear. I think that's all. That's all I needed clarification.
Okay. So in trigonometric functions, let me see if I have some questions from there.
Yeah.
Equals to y cos 2x at pi by 4 pi by 2. So find the equation of tangent line to the curve x sine 2y equals to y cos 2x. How will you do this question?
Sir, I can see that there's two variables included in the function, right? So I think I might bring it to one side and factor out y.
Then, okay.
And then would it be possible to move the
Factor
rest?
out y. No. You cannot factor because one is sine 2y.
Oh, okay.
This is a very good question. So it involves implicit differentiation.
Yeah.
Product rule, correct?
Correct.
So what we are going to do is we are going to differentiate with respect to x on both the sides, correct?
Okay. Yeah.
So try to do that. So when you differentiate with respect to x, so we get d dx of x sine 2y.
Yeah.
Equals to d dx of y cos 2x.
Yeah. Y cos 2x.
Applying the product rule, derivative of x is 1, so we get sine 2y.
Yeah.
Plus x times derivative of cos 2y, which will be 2 times cos 2y, right? Sine 2y will be cos 2y dy dx.
Yeah.
And on this side, we get dy dx times cos 2x plus y times derivative of cos 2x, which is 2 times sine 2x, right?
Yeah.
So that becomes your derivative. Now, we'll take dy dx common, bring them together, right?
Yeah.
So we have dy dx, let's bring it on the left side.
Okay.
We have 2 cos 2y minus cos 2x.
Cos 2x. Yeah.
Equals to, we have y to sine 2x.
Minus sine 2y.
Sine 2y. Now, we need not simplify it further. We know.
Yeah.
So let's find dy dx at this particular point. So pi by 4, pi by 2. X value is pi by 4, right? So let's plug it.
Right.
And y value is pi by 2, right? So we get what?
Yeah.
dy dx 2 times y. So cos of pi minus cos 2x, cos of pi by 2.
Pi by 2. Yeah.
Y value is pi by 2 times 2, right? So the 2 cancel. Sine 2x means pi by 2, right? Sine pi by 2, correct?
Right.
Minus sine 2y means pi, right?
Yeah, sine pi.
Okay. So that becomes your expression. Now, let's rewrite.
Yeah.
So, dy dx. What is cos pi? This is your cosine graph, right?
Right.
So 0, pi by 2, pi is minus 1, right?
Yeah.
You get minus 2. What is cos pi by 2?
0, right? Yeah.
Equals to sine pi by 2 is 1.
Yeah.
Minus sine pi, which is 0, right?
Right.
So dy dx is equals to minus half. You see that?
Yeah.
Now you have to find the equation of tangent line. You already know a point here. So you say y minus y1. So you say y minus y1, which is pi by 2.
Yeah.
Equals to the derivative, which is the slope, half x minus y by 4. You get the equation. Do you understand?
Yes, sir.
Now you can isolate. You may write it in any form.
Yeah.
You can write in standard form or any other form by opening this bracket. So we can write y equals to, let's open this bracket, minus half x, and this becomes plus pi by 8, right?
Yeah.
And plus pi by 2, right? So y equals to minus half x, and plus 8 is common denominator.
So 5 pi by 8.
And 1, 5 pi by 8. Do you see that? How we got this equation?
Yes, sir.
Extremely important question, because see, the idea is at this stage you have learned implicit differentiation, product rule, quotient rule, everything you have learned. So this particular question actually involves almost everything, right?
Right.
And it's a very beautiful question, which I've taken from some of the previous past test papers.
Yeah.
And that should help you to understand how interesting sagging questions could be, right?
Yeah.
So do you understand this concept?
Yes, sir. I get it. I just get a little confused with the implicit differentiation, but I think I understand this part.
Okay, so take a picture of this. We'll end our class
Yeah.
at this moment from here, right? And we'll
Yeah.
do the next topic.
Okay.
Okay, so let me just clear the screen. Can you summarize what did we learn about derivatives of trigonometric functions?
Yes, sir. So yesterday when I was solving the problems we actually just took up, right? I was confused because I was trying to relate the unit circle to the questions, the functions, right? But it wasn't quite working out. So now I'm pretty confident that I can resolve those again. And then with the question of implicit differentiation, I think if I try more problems like that, then the ones in my book will become easier too.
Yes.
So I think that really helped me too.
Great. Okay, so we'll end our class today here. Yeah. I hope you have understood all the concepts. In case there is any difficulty, we can always look into that. WhatsApp me or email me your difficulties. Okay?
Yes, sir.
Perfect.